In this section, we're going to talk about multiplying and dividing rational expressions. So when we're multiplying rational expressions, if we have two rational expressions, P over Q and R over S, then when we multiply them, we get P times R over Q times S, and anything in the denominator has to be not equal to 0. So the procedure for multiplying rational expressions is to completely factor the numerators and denominators. Then you multiply the numerators. You can actually do some canceling whenever possible, and then multiply what's left in the numerators and denominators. And then if there's any more simplifying to do, go ahead and do that. And just make sure that your answer is in lowest terms, that there's nothing more that can be canceled out. Okay, so we're going to find each product and simplify if possible. So I have 4x minus 24 over 20x times 5 over x minus 6. So I can, in the first fraction, I can factor out the 4. That gives me x minus 6. That's over 20x. And that's multiplied by 5 over x minus 6. Okay. So I have some simplifying I can do. I can divide both the top and bottom by x minus 6. Those cancel out. 4 goes into 20 5 times. So I put that 5 in the denominator. And then 5 and 5 simplify. We can divide both of those by 5, and we get a 1 and a 1. So what am I left with in the numerator? Just a 1 over, and then I have just an x in the denominator. So 1 over x is my final answer. Now let's take a look at part B. This looks a little more complicated. But I'm going to just look at each polynomial individually. So don't look at the whole thing and get overwhelmed with it. Just look at the first trinomial. We have x squared plus 9x plus 20. And we know that that can factor into two binomials. Or we hope it does anyway. So I'm going to get x and x. 20 factors into 4 and 5. That sounds good for 9. And the signs are both plus. And then that's going to be over. And now I just look at this trinomial, not looking at anything else. X squared minus 15x plus 44. That's going to be an x and an x. 44 is 4 and 11, I'm thinking, to make 15. That looks good. And we want the signs to be the same. They're both going to be negative, so that's a minus 4 and a minus 11. So it looked like x plus 4 and x minus 4. That almost cancels, but it doesn't. So moving on. Now we've got x squared minus 11x plus 28. So again, I'm going to factor into two binomials, x and x. 28, how about 4 and 7? And they're both going to be minus. And I can see that I have an x minus 4 here and an x minus 4 here. So a lot of times people feel like it has to be diagonal like this, but it doesn't. As long as it's a factor from the numerator and a factor for the denominator, then you can divide those out. So if that x plus 4 had been an x minus 4, even though it's straight up and down, that's perfectly fine. It's a top with a bottom. And let's see, there's nothing else I'm seeing to simplify. So let's go ahead and factor that last trinomial. And you can wait to the end until you've factored all your trinomials to do the simplifying, whatever you prefer. And 35, that's going to be 5 and a 7. And that's going to be plus for both of those. So I have an x plus 5 and an x plus 5. And let's see what we have left. X plus 4 times x minus 7 all over x minus 11 times x plus 7. And that is my final answer. And even though we have two factors with a 7 in it, they're opposite in sign, so they don't cancel. And that is the end of that problem. Okay, now dividing rational expressions. When I have P over Q divided by R over S, I'm going to take the reciprocal of the second fraction. And I change the division to multiply. So I've got P times S over Q times R. And since the Q and the R are in the denominator, we say that neither of those can equal 0. So let's take a look at example 3 here. I want to divide. So in A, I have 9y to the 4 over 6y. And I'm going to change this to multiply and make it 3 over y squared. Okay. So if you like, you can just go ahead and multiply straight across. 3 times 9 is 27. And that's a y to the 4 in the top. 6y times y squared gives me a 6y to the 3. And now I look at what can I simplify. 3 goes into 27 9 times. 3 goes into 6 twice. Y cubed goes into y to the 4th y times. And it divides itself out completely. It just makes a 1. So that leaves me with 9y over 2. Cha-ching, final answer. Okay. In part B, we've got some factoring to do. Not a whole lot here. So I have m minus n, quantity squared, over m plus n. And I'm going to change this into multiply. And I have an m in the numerator and m squared minus m times n in the denominator. So if you want to, at that point, you could do your factoring at the same time that you're flipping. It's just your personal preference. So the first fraction I'm going to keep the same. There's nothing to do here. And in the second fraction, the numerator stays the same. And in the denominator, I can factor out m. All right. So let's see what we can do here. M is its own factor, and it cancels with this m. And then I have m minus n, and that cancels with one of these m minus n's. So it leaves me with 1. So I had 2, one of them canceled. So I have m minus n left in the numerator there. So that gives me m minus n over, in the denominator, I just have m plus n. And that's my final answer. Okay. Now let's try example 4. Same type of problem, just a little bit more complicated. So my first fraction, nice, it's already factored. I just carry this down or over. And notice that this x plus 1 can cancel with this x plus 1. And there's just a 1 left in the top there. And I'm going to flip this fraction. So this is a 2x plus 3 in the numerator. And I'm going to go ahead and factor 20x plus 100. There's a 20 in common. And that leaves me with x plus 5. And let's see, okay. 2x plus 3 cancels with 2x plus 3. Leaves me with a 1 in the numerator. So, my final answer, I just have a 1 in the numerator. And 20 times x plus 5 in the denominator. And that's my answer. Watch out for that 1 in the numerator, that you don't just drop that completely and answer 20 times x plus 5. So the 20 times x plus 5 was in the denominator. There's no reason why it would move up to the numerator in that problem. All right, and let's try B. I've got 3y over 3 minus x. And that's going to be times x squared minus 9. I can factor into x plus 3 times x minus 3. So I'll put x plus 3 times x minus 3. X minus 3 in the numerator. And the 12xy goes to the denominator. All right, now it's time to cancel. So I have 3y. There's a 3 minus x, but this is a term, not a factor, so I can't do that. So this 3 can divide into 12, and it goes in 4 times. Y and y can cancel. And I have a 3 minus x and an x minus 3, which almost cancel. It cancels in that way that makes a negative 1. So my numerator, I have a negative times x plus 3. And then in the denominator, I have 4x. And sometimes you get to this point and you realize you can do more canceling. So in this case, we've finished, but always just check and see if there is something that you missed. And if there is, then you can just proceed from there. You don't have to go back and redo. So you can just do another simplifying step where you divide. So that's my final answer there.